Hey guys, I'm Charles Neal. I'm a professional woodworker and I've made my living all my life working wood. And of any single tool that I've ever used, I believe you can do more with a router than anything out there. There's not much you can't do with one. But you know, today there's just an ocean of routers and it can get pretty confusing. So we're going to take a brief quick look at routers. Now, one of the objectives in this series is to teach you about routers, but why. That's the why thing is the more important issue. And the reason for that is that when you understand the function and you understand how routers work, then what you do with them is limitless. But to start off with, we're going to take a look at some different routers. But before we do that, I want to address safety. Routers are loud. You definitely want something on your ears. They are very loud. And safety glasses. They can throw a lot of chips. Absolutely, you need the both. You know, routers I can fully understand how you can be just totally intimidated and confused by them, because there's just so many different ones. You know, here's probably the most basic of the routers. But let's look at a router very quickly. What is it? Well, so that it's not complicated, it's a motor that turns a bit, or a cutter that you can hold or you can mount under a table. Very simple. That's all it is. When you hear about, they do all kind of different things. We have plunge routers, we have trim routers, we have the basic routers. It's just endless. And you're going to see horsepower ratings and all of these things, variable speeds. Why are they important? Well, it depends upon your applications. You know, the object of cutting some wood nice is turn the bit fast and move the wood. I don't want to use the term slow, because then you can get the black spots that are the burns. But the best way to cut something smooth is to turn it fast and move the wood at an appropriate rate. The reason for it is the faster the bit turns, the more times the cutter engages the wood, thus smoother cut. But also common sense says there's a limit to that. Now, you certainly wouldn't take this big multiform bit right here and turn it as fast as you would this little bit. So variable speeds help immensely. Then let's look at the router really, really in depth. You've got this one. You've got a housing that locks well. There we go. And you're going to see them. For example, here's a plunge router that comes in a kit that also has another housing that houses the motor. I can interchange them. This is a plunge base. What is a plunge base? It means that the router can be elevated up off of a surface, flip of a button, the router goes down and can be locked into position to a specific depth. And we will see where that comes into play. And you see routers mounted under tables, router tables. Well, this base that's on this one also allows me to use it as a fixed stationary base, very similar to this, where it doesn't plunge, but it also can be mounted under a table, and it has a crank that comes down through that allows me to raise and lower the router in a router table. But let's look at the router a little bit more in depth. This is the serious end of it. This is called a collet. And what it does is it simply holds the bit. Now, if you look very carefully at a collet, you're going to notice that there's splits in it. And what happens is when the router bit goes in, and this is tightened down because it's on a taper, those splits close and tighten around the bit. Now, when you install a router bit, and your collets, I want to mention your collets, you've got 1/4 inch and 1/2 inch. Where applicable, where I can use them. Now, in the case of like this little bit, this little spiral cut bit, it only comes in a 1/4 inch collet in that particular size. But where possible, I prefer a 1/2 inch shank. Usually they're not a whole lot more money, but there's a whole lot more meat there. And that means that there's less chance for vibration or movement. So I prefer 1/2 inch shanks. I just like the extra strength. When you install a router bit, the first thing is don't bottom it. That prevents the collet from being able to get its best grip. Take it to the bottom and slightly bring it out. Then tighten your collet. Tighten your collet good, but getting on it and, putting the bars, you don't have to go all of that. Okay? They do extremely well. Now, you've got your power switches and all of that. That's pretty self-explanatory. Except, I want to address one thing. Now, throughout this series, the router you're going to see me using predominantly is a D-handle. What is a D-handle? Well, essentially, it's the exact same motor that's in this router. The difference is that this one, and you notice this one secures the base and adjustment with a clip. This one is different. It uses a bolt. But here's the reason I personally prefer a D-handle. And I'm not telling you to go buy a D-handle. I'm just telling you why you'll see me use it the most. Is I've got a bad left hand from a table saw accident. And the thing I like about the D-handle is I like the fact that my on-off switch is right here. On this one, I have to turn it on and then reach down and hold it. Not a big deal, okay? Except that this, for me, is more comfortable. It also gives me more control and grip. And I like the on-off switch right at my fingertip. Personal preference. And then you'll notice that the knob on it, here in my case, is on the left. If you're left-handed, they'll switch around to the right side. Okay, now here's a big 3 horsepower plunge. And I want to look at that with you. I just want you to get the basics. Now, the way this plunge router works is very simple. We have here a lever that locks and unlocks it. Down, lock into position, release, and it comes up. And we'll see how all that affects. We also have, you're going to see these on here. These are for different depth settings. In other words, you can come along and you can set this up to where these are depth controls. This is a minor one. This is your major one. There we go. And what this will do is you'll notice almost all your plunges. Let me turn this where you can see it good. There's 3. 1, 2, 3. And each one of these is adjustable to allow different depths. So that if you're doing a really heavy cut, you can start out with a shallow cut. Then you can progress to a deeper cut, and then you can progress to a final cut. That's what that's about. This is simply a vacuum port. Pretty nice feature. Now, this particular plunge router, I also have my trigger right here at my finger. And I can also lock it down if I want to take this and mount it underneath a table. Now, there's also going to be speed settings here. This is a variable speed. And just like we looked at those big bits, it's pretty simple. Here's another plunge. And each one has its own little features and operates just a little differently. Again, speed control. You've got your up and down. You can lock it. The same deal with the way it controls its depth, pretty close, is that this one sets just a little differently by adjusting, your settings. And that's going to depend entirely on you and your depth. Now, this one is also designed that it can go under a table. Okay, you can mount it under, and they have cranks and all kind of different things that raise and lower them. So, each one has its own thing. Now, this one also has a little switch protector so you don't inadvertently turn it on, and you've got the switch right here at your fingertips. Here's one. Again, now this one, like I said, it has the auxiliary base for going under with the crank built in. But basically the same thing. Now the only difference with this one is that you've got the switch up here and then you've got your movement. Not a bad deal. Now right here, you're going to notice again the same deal. Your points of contact. But this one is made a little different because this one you actually twist the you twist your lock arm to the various settings. Again, adjustable. All right. Then we get down to our little trim routers. Now these were predominantly designed and came out for laminate trimming, where you're using a bit, and we'll look at that you use to trim Formica and solid surface materials. Very simple. These are just as basic as it gets. You loosen this, you got a knob here, does your raising and lowering. Just very simple. But also, you wouldn't buy one of these and expect it to run one of these. Now here's one. Now this is right now, at the time this is being filmed, this is the Porter Cable 7518. It's a 3 horsepower variable speed. But what we have mounted here is a router lift, okay? And again, just as we saw right here, this one is designed, has a separate base that you can just use a crank down through the tabletop of your router table to raise and lower the router. This one, you actually have a thumb crank that raises and lowers the router, as well as you have a big lock fence thing here that you'll see in operation that helps to raise the router. Which one do you want? And I know you're confused. There's a lot to be said. If you're going to be doing a lot of big raised panels where you're running big, huge bits, you want the power and you want the variable speed. No doubt about it. The bigger and more powerful it is, the more stable it is also. Trying to run these big bits in small routers, you can get some chatter in them. But by the same token, this is a lot of money. You buy a fancy router lift like this, or you buy, and the big routers, depending upon what you're doing, you may need that. In essence, what this is doing is it actually is taking a router and making it into a shaper without having to go to the full expense and size of the big massive shapers. But they really do a nice job. But to also take our little basic router and mount it under a table, I did this forever, where all you got to do is reach under and just kind of raise it and lower it. Works well. And I'll tell you, these, you know, I think this is what, a horse and a half, horse and a quarter, something like that. I've done a lot of raised panels with them. I wouldn't want to do a whole bunch of them because you're taxing the machine too much. Just too much, you know, they're not made to be a shaper. They're not made to be this. So again, it depends upon your application. You know, if you're going to be doing a whole lot of raised panels for a set of kitchen cabinets, or you're really serious into it, you know, your investment in something like this or one of these bigger horsepowers makes sense. Your intermediate line is going to be your 2 horsepowers. They work well. Okay, that's kind of a brief synopsis of routers. This router is a horse and a half, and I'm not exactly positively sure what the RPM is on it. It's 23,000. And you're going to see all the variable speeds out here. Now here's one goes from 23, and I can dial it down to 10,000. What's the point? Well, first of all, I hope you got enough sense to know that you don't put something like this big 3-wing raised panel bit in a handheld router. Unless you plan one of 2 things. Either you plan to fly or you plan to get hurt. Not for a handheld. Just don't even think about it. But even in a table, okay, a bit like this, you don't want to get much over 10,000 RPM. You just don't. And that's simply because of the big wing out here. Same thing with this multiform bit. You're not going to turn it that fast. Just don't. You know, now because this is in a vertical situation and you don't have all the big, you know, air volume around that you do in this raised panel, this one, you know, 15,000 RPM wouldn't be a big deal. You take something like these little spirals or these right here to take them up to the, you know, 20,000 RPM, to take this up to the full 22, you're okay. But remember something. I'm going to say this again. If when you're spinning that bit and it just sounds and it looks too fast, then it probably is. Now, in the case of these, you don't have much choice. But think about something. If something were to come loose or come out, that thing is moving. So try to rig you up some guards and different things like that over top of them. Safety, there's no operation you need to do that ever involves you having to do something unsafe. All right, guys, I told you I was going to tell you a little bit more about the trim routers. They're pretty cool. The trim routers are predominantly designed for laminate trimming, for mica, countertops, that type of thing. And a lot of you guys do that, or you're into remodeling, kitchens, construction, that type of thing. Now, when you're trimming for mica or anything very thin, the typical bit that is used it's a round nose right here. It does not have a bearing. And it has a 2-flute cutter right here on each side. They do okay. But the problem you've got is that a lot of times, particularly with Formica, where you've got contact cement and that kind of glue and whatever, when you're running, 2 things happen. One is that because this is called a pilot, because it's not a bearing, and it runs down through here, and what it will do is it will burn on the edge a little bit if you're not moving pretty quick. And the other thing it does is they have a tendency to get all kind of gobbed up with glue. An alternative is a bottom flush trim bit. Here it is. Now you have to be careful with this. Now I'm going to tell you why. If you look right here, very carefully, you'll notice that there's a small offset in the cutting edge and the pilot. That's so that when you route the countertop, it leaves just a hair of an edge there. Usually they'll file it. And that's so that when you use a bottom bearing bit like this, if you get way down on your edge, you have a chance of marring your finished surface. So when you use a bottom bit, make sure that you set your bearing to where you're just taking off the very edge of the formica. Now this little space in here will also give you a little bit of relief for the glue that tries to build up on them. Now I don't have one, but out on the market they also now have what's called a square bearing. And it sounds nuts, but it's a plastic and it has a square bearing on it. But actually what it does is the square part rides against the edge, and this is turning inside, and it's designed for the laminate trimming. I think that would be a really good alternative. Now, I told you this is a kit I've got. Now it's pretty cool. You've got, there's all kind out here. It's got an offset base. Now what is that? The router actually mounts here and the bit comes into this point. And it allows you to get into inside corners. Or if you've got a backsplash that's doing a 90 degree, it allows you to get up on top of the backsplash, route it to the corner and turn and come this way. So it's predominantly designed for an inside corner. All right, they also have an angled base. Now, this is, again, this will help you on an inside corner. If you've got a, say, a baseboard or something, and you've got an odd angle, the bit is going to come in on this at the angle you have set. So it actually gives you a little bit more reach. And like I said, if you've got an odd angle here setting here, you can actually take this and angle to your corner and make your cut. Then they have a neat little thing, it's called an underscribe or undercutter. And the way this works is that it attaches to the base, and you can actually do if this had a laminate on it, and and then you glue a piece of laminate across and it overlaps. This is made so that it can actually come on here, come in this way, and you can scribe that cut, your excess off, and it'll make you a perfect butt joint. Edge guides, they got all kind of different things for them. Normally I have one sitting around because, you know, when we're easing edges means usually we take a little small quarter round bit and just route the very sharp off of all of our edges. I like one just for getting around there. They're pretty quick, pretty nice to have. But again, they typically only come in a 1/4 inch shank. You know that. And they're not made for these big, heavy bits. But when you've got small, delicate, and light routing to do, they do great. Now you're going to also notice that the base of it is made to fit your guides as well. Really nice little router to have around. Okay, if you look at a router bit, essentially what you have is you have a machine piece of high-speed steel. And to it is brazed a piece of carbide steel. Carbide holding a good edge and doing all of those things. Now, carbide is also a little bit more difficult to sharpen because it's so hard. Now I want to show you a little something here before. If you will notice back behind this cutting edge right here, you see this area right here? Well, that's an anti-kickback. Now the reason what that does is that allows the bit, as it's rotating, to not be able to take but so much of a chip. So that if something goes wrong, it's not going to just dive in and make it jump back at you. That's exactly what it's about. It's about preventing a lot of grabbing and just biting in and jumping back at you. But then you have a bearing. Now, before we get into this really good, let's talk about this a minute. there's predominantly 3 ways of guiding a router. Remember we said a router is basically just a motor that you can hold or mount under a table. But these guys are the things that do the work. Now I'll give you a hint. Buy your own, if your family's into giving you woodworking tools for holiday presents or birthdays or whatever, let them buy the router, let them buy the bits. Bits can get pretty pricey. Now, somebody's going to ask me which, I've got bits here there's Rockler, Whiteside, Eagle, Woodcraft, Freud, or Fruit, ever how you say it, CMT, Amana. I guess I've probably got about every manufacturer of a router bit. I've got one of their bits. That's just the way it is. Okay. Which bit do you buy? The best one you can afford. If it's something you're going to be using a whole lot of, you might want to look at a little bit, higher priced or a little bit better bit. If it's something you're going to use once, then, you probably don't need to put all that kind of money into it. They can get expensive. They are very expensive, actually. Doesn't matter which one you get. Now, predominantly, you're going to see bearings. And you're going to see a bottom bearing. Do I have a top bearing? Yeah. And you're going to see top bearing bits, where the bearing's up here. And you'll see what the purpose of all of that is. And what a bearing does, and I feel sure most of you know this, but in case any don't, is that as you're cutting, the bearing runs along the surface and guides it. That's how it's guided, by the bearing. So keeping your bearings in good shape is really important, and keeping your bits in good shape. So I want to talk about that just a second. If you will look at this rabbiting bit, inside of here and on this cutting edge, as well as this old raised panel bit, there's crud. Yeah, that's a wood term, crud. There's crud on it. What is it? Well, wood has minerals, sap, all that stuff in it. And if you look at one of these things turning, it's removing a lot of wood, and it builds up some heat. And so this crud, if you will, builds up on your cutting surface. Taking a good resin remover and cleaning it off, or something as simple as a little goof off, or whatever the case, mineral spirits, a little lacquer thinner, keep it off of there. Keep it clean. Now, the other thing is, when you're storing your bits, to have a nice place to store them is just really smart, and preferably in the containers they came in, or a nice tray or rack or something. But keeping your bits sharp. Now, if you send your bits out to be commercially sharpened, what they usually do is right here on this edge, right in here, it's usually ground on the inside, right there. And if you look carefully at the cutting edge, it's on a taper. So when they grind this edge inside of here, it produces a sharp edge. Keeping the resin off and taking something like a nice diamond hone, ever how you want to say it, and honing them, and keeping the resin off is just a smart thing. I'm going to tell you the truth. The carbide in these things nowadays is so good that they rarely really get dull. Most of the time it's the resin and pitch buildup on them, and that's the issue. How can you tell if a bit is sharp enough to use? Well, it's real simple. You can take a little piece of wood and scratch it, or you can take it right on your thumbnail or a fingernail, and just, if it will actually take and make a peel, it's sharp enough to give you a decent cut. Pretty simple. But keeping them clean, you know, I've gotten into situations where I've been doing raised panels, and you know, a lot of them, and I've had, you know, if I'm doing cherry particularly, or pine or anything, I've had to stop and clean them, you know, 2 or 3 times in the process of making some raised panels. Keeping that pitch and that resin off there really, really makes for a nice cut. The other thing you want to do is your bearings. Okay, you know, feel the bearing. If it's not running nice and smooth, then you need to clean it and do something with it. You can take something like a penetrating oil, or WD-40 or something like that, and spray down in there and clean them up good and make sure they're running well. Keep them oiled. Okay, little 3-in-1 or whatever you got, you know, keep them oiled. Storing your bits, wipe them down. You're going to see some of my bits throughout this. They're going to look kind of cruddy to you, but the reality is because I'll coat them with a little coat of oil, and they'll pick up a little bit of sawdust and stuff on them. Don't always look the prettiest, but keeps them from rusting. Now, you're going to notice here on this Woodcraft bit, it's got a painted body. So that's not a real big issue. But like in the white sides and the eagles and a lot of these, you know, they come in a raw steel. Keep a good coat of oil on them, or a good coat of wax. Now, the other thing I want to tell you about is, if you're into it, they've got these, and I think about all the companies make them. They got these little, I think they're called emergency repair kits, or I don't know exactly. But anyway, when you get them, they're full of bearings, and you can see the oil and stuff's on them already. Bearings and screws and whatever. Because, you know, changing your bearings, well, that's, you know, you're going to see in this series, we're going to do that's a big thing. Being able to change the bearings out. You can change a profile of router bits and change cutting depths, and being able to change this bearing is just a great thing. And one of these kits is you can, well, here's a new one. As you can see, these things just come with a multitude of bits and bearings and screws and stop collars and all of that. Now, what's a stop collar and the screws and all of that about? Well, when you get into stuff, you know, like here's a, I don't even know what I was doing, but here's a flush trim bit, and you'll see what they're for. And you're going to notice I got 2 bearings on it, and this is the stop collar. Simply uses a little set screw to keep my bearings from moving up and down. But being able to, you know, here's one. This is a classic example. See how big the bearing is? And I've actually got a stop collar top and bottom. This is something I rigged up for doing a specific operation. So being able to switch these bearings to all kind of different configurations, you can just, you know, you can dramatically change the way bits cut. And I want you to understand that, because as we go through, you're going to see us changing a lot of bearings to do different things. Keep your bearings oiled. Like I said, make sure that they're functioning good, and keep them with a good coat of oil, and they will last you indefinitely. All right, keep the bearings clean, keep your bits oiled, and keep them sharp, and keep the crud off. All right, the other way that is used a lot for guiding a router. Now again, remember, I'm going to say this again and again throughout this. The router is a motor, and the bearing is the cutter, and the biggest thing in learning to use these is to learn how to guide them, how to make them do what you want and do it safely. It's called router guides. Now the way these work is very simple. You have a guide, and depending upon which router you've got, make sure if you get a set of guides, you've got one that fits it. And it simply sets down in, then you have a lock ring that comes under, screws it in place, and you have a guide. Now, one of the things you want to do if you're using a guide is you want to make sure that your bits are centered. The base plate, you got to remember, this router is a It, you know, goes through a manufacturing process. The guys go through manufacturing processes. And while they're all supposed to be wonderful, nice, and perfect, we all know that's just not a real world. Now, out here, you've got them out here everywhere. All kind of starter pins and whatever. And the reason I'm looking in my pocket is I know, what can I say? But like this one's got a 1/2 inch collet. I could actually stick a 1/4 inch collet in this. Stick a 1/4 inch collet in, put this in it, take a 1/2 inch inside diameter collar. It doesn't matter what I'd be doing, and this will make sure that my router bit is dead center to my base. That's important, because if not, then I'm going to be running off. If you don't have all of that, then the other thing that you can do is simply take a bit that's got a bearing on it that matches one of these and do the exact same thing. Have it come up through and use the bearing on the bit and make sure that it's hitting dead center. What do you do if it's not? Well, yeah, I know. Scream and holler is part of that process, but what you're going to have to do then, and make sure that it's, you know, your base is secure to the router. What you're going to have to do then is you're simply going to have to take some of your base attachment screws. I've had to do it, and kind of slide them a little bit, take a countersink and re-countersink it a little bit. I've actually gone to the point of actually taking this and wind up re-drilling holes to get it centered. Not a good thing, but you want to make sure that that base is centered. Okay? The third way that we typically guide a router is fences. Now, router tables, we make fences, and throughout this series we're going to be rigging up all kind of stuff to guide a router. But it falls under the category of a fence. You know, here's a commercial fence that you can get. These go left and right. You can dial it in and out, okay, for depth. Here's another one over here that's made that you can set up to micro adjust in and out. The other type of a fence, while you may not think of it as a fence, I do, is a simple guide. And usually these slide into the router, and every manufacturer who makes a router that I'm aware of makes some kind of guide. And you can attach this to your router and adjust this part to run along the edge of the wood to guide it when a bearing is not going to be capable of doing it. And just to mention that's just like this big multiform. You know, this bearing would only work if I'm using this part of the profile. If I just want to use part of this, and that's one of the things about this particular bit, is that it's called a multi-profile, and it means what it says. You can do all kind of different profiles with it. But not all of them are you going to be able to guide with a bearing. So fences. You can get, you know, fancier fences that attach to your routers that you can micro adjust and all of these things. You know, back here's another guide system that I think comes with the Triton router. So being able to guide it is important. And worst case scenario, if you don't have any of that, you can actually make yourself one, and we'll look at that. Okay, guiding them. Fences, guides, and bearings. All right, which is the best? Well, personally, I'm going to put the fences in with the bearings, because there's just no, you know, once I'm dialed in, I don't have a lot of issue there. But probably the easiest, obviously, particularly just for an edge routing, is the bearing, because it's going to track the wood. But by the same token, a fence, it pretty much does the same thing. The guides work well, but my preference is the bearing. When at all possible, go with the bearing. Now, you know, just like here's a rabbiting bit set from CMT, here's one from Whiteside, and you're going to notice there's just, and I've got more, there's just a slew of bearings here. I mean, I can switch this bearing out and I can make this a flush trim, and I can make it step down to whatever depths and different increments that I want, and that's important. And you're going to see really just the advantage of being able to you know, use these bearings and whatever in different sizes. And you have to get a little creative sometimes to make these things do what you want. And we're going to get real creative. Okay, guys, we're going to get some of this mess cleaned up, and we're going to come back and we're going to make some chips fly. We're going to take a look at handheld routing, simply just freehand routing with your router. Now, again, we talked about earlier guiding the router. Now, what I've got in here is I've actually just got I think it's about a 5/16 radius roundover bit. Very, very common, 1/4, 3/8, 5/16 roundovers. But it's a bearing guided. Now, simply the way this works is that the bearing runs along the wood and the cutter does the work. Now, here's a case where if you look, I can lay my piece of wood up here and you can see that the edge of this bit is not encountering the wood. Now, what this is going to allow me to do is do light cuts. Because if I hog it all, odds are I'm going to get a lot of chip and tear out. Now, the other thing you're going to notice is that I've got a pretty big opening here. And I've also got a large base plate. It's an aftermarket one I picked up. I like that. The reason I like it is because when I'm actually routing, I can look down and see what's going on. Okay, it's just a visual thing. If I'm using a regular base that usually comes on my router, because it's made to fit the bushings guides that we showed you earlier, I really don't have as good a visual. Simple as that. But one of the other important things is that to be able to secure your work. I can't emphasize that enough. Trying to route something that's wiggling and moving all over the place, you're not going to get a good job, and it's not safe, simply put. Now, out here you're going to see all kind of router mats. Here's one. And what it does is it's made with a grippy surface to keep it from sliding around. Well worth your investment. But here's a clue to keep you out of trouble. Always double check your depth. If the screw or the bearing, when you're routing it, is going to be engaging your mat or your bench, you got a problem. And that's often the case. And I'll tell you what, if it's engaging that mat and you turn this router on and go into it, you're going to get a gnawed up, gnarly, well, it ain't good. Now, I'm going to tell you something else too. If you don't have a mat, try a little thin piece of carpet padding. All right. So the best way, depending upon what you're doing, is to route, where it's overhanging an edge or something, but you want it secure. There's 1,000,001 ways you can do it. In this case, we're just going to use, we got a bench, so we're just using a hold down, but keep it secure. Here's the other thing, rotation. Rotation. In a handheld, you run left to right. In a table, you run right to left. Why? See, this is all about why. If you look at this bit, when this bit is turning, You always want the cutting edge of a woodworking tool to be fed into the wood, meaning you don't want it to be able to feed into the wood itself. When this bit is cutting, it's cutting, you're feeding it, you're going to be, let me get this right, this bit is turning, you're going to be feeding this direction against the rotation, not with the rotation. And the reason for that is that if you don't, if you look very carefully, almost every bit, you've got this edge, this corner, right here. And what it will do if you're running in reverse and not doing what you're supposed to be doing, what it can do, if you're running this way, okay, with the bit, what the bit can do is it can grab and pull the wood. Which means if you've got it, if you're running it handheld like this, and you run in the direction of the bits, you run this way, which would be a right to left thing, up in handheld, this bit's going to try to bite into the wood, and it's going to jerk back at you. Now, and then in a handheld, in a router table, because you're reversing it, it's just the opposite. Now, that's important. One, it has to do with safety. The other, it just doesn't work very well. It's not safe, guys. Now, I want to show you something that will help you. And the reason I want to do this is that a lot of times, a lot of guys do something called climb cutting. Climb cutting gets its name from the fact that running the bit in reverse, it can climb back at you. Exactly what we were talking about, don't do. But there's an advantage to it. The same rotation will cause the rotating bit to bite into the wood running in reverse. In other words, the impact is coming into the wood. Now, that's a good thing, because by cutting into the wood, it helps us dramatically reduce chip out and tear out. The correct method is to be running this way, and when you do, with the bit cutting this way, the bit is cutting out from the wood. So it's hitting in and pulling out. Greatly increases the chance of this chipping and splitting, just the way it is. But is there an alternative? There is. Let's take a look at it. This is the dumbest thing you ever heard of in your life. I call it bump cut. Yeah, I know. What a name. Well, if you come up with another name, you let me know. Now, again, handheld left to right. Now, here's the problem. Again, if we come this direction, we get a cleaner cut. But this bit can track, and this router can come back at us. Here's a solution. By going straight in, I don't create, and not pulling the router, I don't get the track. Then I come back and I run. What the bump does, is it keeps us from having that shear angle on the wood. So that when we come down, and as the router bit is throwing it this way, what it's going to do is there's nothing really here to be splintering. Helps immensely, and is a much safer alternative to climb cutting. Oh yeah, and while we're doing this, If you put a line on your router base and make a series of lines down, you can make some pretty cool molding. Bump cut. You saw it here. Any woodworking bit needs to be pushed into the wood. What am I talking about? So if this bit is turning this direction, okay, I want to be going that direction, opposite. Here's the rule. Handheld, you always want to go left to right. Inverted in a table, right to left. Simply put. Now here's an issue. When you're routing, you always want to do your end grain first. The reason is that because this bit is turning, what it's going to do is it's going to try to chip this edge because it's cutting outward. It's cutting this way. Let's look. Now you notice, this is a very minor cut. Normally what I would do would be go all the way around, take a light cut. Then I would adjust my depth again for my final cut. Now I'm just sighting over this and looking at my edge. You may want to lay a piece of wood up here to check. Now we don't have much of a chip out, but we got a little. All right, the reason you want to do your end grain first is because if you get that, when you then rotate and go the other way, you're going to take it out. So always route in a 4 square. In other words, do this end, that end, cross the back. Now, this is just a round over. Now earlier we were talking a little bit about bearings and changing bearings and different things. I'm going to grab one of these little kits real quick. Always, always, always make sure that your you're unplugged before you do this. Now what I'm going to do, this is a round over. And let me show you this very quickly. Here's what I can do. I can also use it to do what's typically called a little thumbnail edge. And that's simply by, again, lowering down just a little further to where the straight edge part of the bit is going to make a cut. Let's look. All right, I get that profile. By simply changing the bearing to a smaller, I can convert this round over into what's called a beading bit. What I'm wanting you to get, you see I've also got a cutting edge right here. So I can take this bearing, I can change this to a smaller bearing and give myself the little step cut right here. And what I'm wanting you to get out of this, now when you put it down, make sure it's rotating, because if the head of the screw is too large, it can actually come out here and pinch your bearing from rotating. All right, now we're set up in a beading bit. Now by the same token, I can also take a beading bit, put a larger bearing, make a round over. That's something. This only works when we have a bit that is cutting, listen to me carefully here, that is cutting from the top down. In other words, you can sneak up on the cut and take light cuts by raising and lowering the router. Not all bits work that way. A lot of you are telling me you like that big base and that big open hole, but you don't have one of them. And you don't know where to get one. Make one. You can pick you up plexiglass or, one of those composites, make the best. And a clear one is pretty nice. But if you don't have that, decent sheet of 1/4-inch plywood does a nice job. We use them a lot. Simply remove the base from your router, and it's already got your holes, your attachment holes. You ain't got to get crazy with it. And whatever size you want, lay it down, mark your center, take a bit that's the same size as the hole you've got. Drill it. Now, one thing you want to pay attention to, you'll notice on this router I've got an attachment hole here, here, and here. Now, if I'm doing just a round one, it's not going to really matter, okay? But if I'm doing something that you're going to be seeing later where I want a big base and I want it in the center and I want to hold my router in a specific area, just pay attention that you locate the holes so that the router will be sitting on your platform or on your base, ever how you want it. But just simply take it, put it down, clamp it in place, drill your holes, a little regular wood bit or countersink the other side so that when you attach your screws, they go in flush. Screw it to the router. Attach it to the router. Now I want you to listen to what I'm going to tell you. Then, if you have a short 1/4-inch drill bit, if you want to make sure your hole's dead center, put it in your 1/4-inch collet. Don't turn the router on. Drill bits are not made to be used in router bits, period. They're just not. When you turn that router on at that speed, that drill bit's going to bend and it's going to go everywhere. Do not turn it on. But rather, just use it as an indicator to come down and mark your center. Simple as that. If you happen to have one of the little center finders like we found, it'll do the same thing. You just want something that'll mark your center point. All right, once you've done that, take a hole saw, scroll saw, anything you want, cut your hole. You now have a base. End of story. Very simple to do. Remember what I'm telling you here, guys. It's about guiding the router. One more time, it's a motor that you can hold on to. So let's go over real quick handheld, the applications of handheld routers. The first thing we understand, we now know about bump cutting instead of climb cutting. We now know not to try to use a handheld router to hold these big, massive bits. Just not safe. Okay? And here's a rule to that. If it looks like it isn't safe, it isn't. Okay? If you get anything, I'm going to say anything much over 1 inch or 1 1/4 inches, you might want to really rethink holding that in your hands. And even then, holding it in a very, very small, light router is still a little bit much. A router table is probably one of your safest and easiest to control. And in just a minute, that's where we're going. We now looked at a way of making sure that we have nice, perfect patterns. Now, one of the things with a router, and you're going to see it in this series, is we use lots of patterns. We're going to use lots of patterns and lots of jigs. Remember the thing again. A router is just simply a motor with a cutter that you guide. And the key to it is being safe with it and how you guide it. And there's a multitude of ways of doing that. We've already seen in the handheld, again, I'm going to repeat this, we've seen the guides, we've seen the bearings and all of those things. Interchanging bearings to get different profiles. of changing bearings to be able to ease into a cut, to take light passes, to always go from left to right in a handheld, and always route in a box. Route an end grain, flat grain, end grain, flat grain. That's how much we know now. Now we're going to go over to the router table and explore some of the basic uses of it. Okay guys, we're going to take a look at router tables and the use of router tables and whatever. Now I'm not going to go out here and give you a whole bunch of plans on how to build a router table. There's as many router table plans out there as there are router bits. But I'm going to show you some things I like. Because, you know, you can buy the ready-mades. But a lot of you guys like building your own. And that's a good thing. No problem. Here's some things you want to look for. You want to, you know, to take two pieces of MDF, 3/4 MDF, and glue them together, flat and level, and then cover them with a piece of Formica or some other kind of laminate. Makes for a really nice router table. Now, I'm a proponent of plates, the router plates. What am I talking about? I'm talking about the plates that the router attaches to. Now here's why. If you have, first of all, in order for you, whatever the thickness of the top is, you're going to have to cut that out. Because if you got two pieces of 3/4, you're an 1.5 inches. Well, you've just dramatically reduced your ability for most of your bits, because you've reduced the height you can achieve. Okay, so it's really affected your cutting length. The other thing is, routers are heavy. And you want something that's going to support the weight, but yet isn't super thick. Now you've got aluminum, phenolic, you've just got, you know, it's everything out there. I've actually found, I think that the phenolics and the aluminums to be the best. They just, you know, I've had some of the other ones that are just a high impact plastic or whatever you want to call it, and they dip. Just a fact. But I'm going to show you my old router table here a little bit, and you can get some ideas. Now actually what I made mine out of is an old solid core door. And what I've got on it is an old table saw fence. Now, and the reason I'm telling you this is it allows me to make jigs and move it and do all kinds of things. And I have two lifts in this, but I use it a lot for raised panel doors and all kinds of different things. Again, making a living doing it. Here's a couple things you want to look for. And, you know, again, once this is done, you'll know how to do it. You want to plow it, whatever you've got, you want some tracks in it that your miter gauges can run in. You'll notice both of these that are commercially produced, they've got tracks for the miter gauges. And here's the other one over here. You want a good fence. You want some way of having a good fence. Now, you know, again, you can buy the commercially made just fence. You can, you know, with the fences, all of that's out there. But in reality, you can take some MDF and make some pretty neat fences. If you want to know the truth, probably use them more than anything else. Just a fact. Now, like I said, I prefer the plates. Because even if I leave 3/4 inch MDF and I bolt my router right up to it, particularly if I'm using the big routers, I've got problems. Because again, I've reduced my cutting height. And if you don't keep that router supported in here, then I'm going to tell you again, it's going to sag. If you build a router table, make sure you've got as much support in and around as you can. Okay. But assuming that you're going to buy plate, or you're going to use, in this case, a lift. So what I've got here is a router lift. but it could just as well be a plate. Now I'm going to emphasize again, reinforce under them. Now in order for this this plate to sit in, I have to have a lip around here that will allow it to set in. Now one of the things, and so I'm going to show you how to install a plate. But I want to talk just a little bit more about my router table here. Like I said, I got the old fence off of a table saw, and we can make the others. But here's something I want to show you. I can't show you on that side, but I can over here. I had it wired. I've got a switch, and what happens is when I plug the router in to one, and then I plug my vacuum into the other, so that when I turn the switch on, I get both of them coming on. I've done the same thing on almost all my router tables. That's pretty neat, so that you can get, so you don't have to, because if you're like me, you forget to turn one on and all of that. But you got to make sure your electrical will handle it. Okay, a lot of these, the router, some of these are 15 amp, and if you're running on a 110, 15 amp breaker, and then you throw a vacuum cleaner on top of it, you may have an issue. So make sure that you check out your electrical and make sure you've got it done safely. Okay. Installing this plate. What we're going to do is we're simply going to trace around it. Now here's what we're doing, and you're going to see a lot of this in this series. We're making a pattern to make a pattern. I'm going to trace it out. Now, most of the people who make lifts and who make the plates, you can buy a commercially made pattern. Here is one. And sometimes they just have a little template drawing that you use. But I just simply trace out the pattern or the lift. Then I find a Forstner bit that matches the radius of my corner. Now what I'm going to do is I'm going to go over here and I'm going to drill it. And I'm going to use the drill press to do it because I want it to be nice and straight. Once I've done that, then we'll take a jigsaw and we're just going to rough cut this out. Okay? Then we're going to come back and using what we learned making a pattern to make our final template. All right? But we don't want to get outside of our lines. We want this to be really, really nice. So we're going to see how we get it. All right, guys, here's what I'm doing. I want to show you. All I've done is I've got a straight edge, piece of MDF. And because this is just a template pattern, now understand what we're going to do. I want you to follow this. I just took some screws, some 1 1/4 screws, and I screwed it on my line. Now I just took a Forstner bit and drilled it. Now actually the Forstner bit I used could have been a little bigger, so I'm actually not going all the way into my corner. I'll handle that once I get it cut out. The other thing, the bit that I've got isn't going quite deep enough. We'll worry about that in a minute. And all I'm doing is again using that flush trim bit and this straight edge, tracking off of it using those bearings to guide on this edge to make my line straight. You're going to see a lot of this. All right, now what I'm going to do, since I wasn't careful enough with my Forstner bit, is I'm just going to take a rasp and I'm going to clean up my corners and make sure I'm to my line. Then, all I got to do in order to clean this bottom out, you know, this lip that's overhanging here, all I got to do with it is just run my router back around it, clean it right out. Not a big deal. Okay, what I'm going to do is I'm going to rasp this, doing just like we did on the other little pattern, make sure everything's decent. I'm going to check my fit, and then we're going to make our cutout for our router plate. All right, guys, here's what we got. Now, I've made my opening, and I've put my plate down in it and made sure it fits. And what I've got, now we're going to assume this is your router tabletop. So so I've got some double face tape, and I'm simply going to position it where I want it. Make sure it's secure. Now, while we're doing this, this is a point I want to show you something. What I've got here is I think this is a 5/8 by 1/2 inch flush trim bit, and with the bearing. And I've got it in a plunge router. Now here's a problem with a plunge. Plunge routers work really, really well with guides, when the guide is big enough that the router can then protrude through the bit. When you're using a bearing, here's your problem. Your problem's going to come in is that if your router is fully up, when you plunge, you can actually miss. Not a good thing. So what I'm going to do is I'm actually going to bring this down. That's the reason I'm using that little short 1/2 inch bit. And I've got the router locked. And I've also got my depth stop set right here for just about, I'm going to set it for about a 1/16, a little bit over 1/16. Now the reason I'm doing that is so that when I start routing, I've got a bearing surface that I'm riding on, and when I flip it, when I flip my button to go down, I don't want to bounce up. I just want to be able to plunge it straight on down. Okay? If I don't, then I'm going to have a problem, and I could miss and tear up my edge. Okay? All right, just so you get the premise of what we're doing here, what this is going to do is this is going to cut me a shelf in here. Now this is MDF, so I can go, without too much issue. It's pretty soft. But what I'm going to do is I'll continue around, all right? Then I'll change my depth until I'm at the thickness of my plate. Then all I have to do is drill me a hole in each corner, then taking, jigsaw or whatever, just cut the center out, and my plate is ready then to drop down in. Don't do like I just did. Make sure you got it secured down. I forgot that part. Don't you? All right. I'm going to take it on down, and we'll be right back. All right, guys. Pretty simple, actually. We whacked out the inside with a jigsaw, and there it is. Fits nice. Now, a good lift or plate, one of the things you probably want to do is try to cut your recess just a little bit deeper than what your plate is, because most of the good plates are going to have an adjustment where you can adjust the height so you can set it all really nice and level. One of the guys here asked me, he said, what can you do, what can't you do on a router table that you can do with a handheld? And there's really not many you can't. And most guys find a router table to be safer, and they feel more secure and more in control. The biggest difference in a router table and the router is that in this case you're moving the wood, and in the case of the router you're moving the router. Now that's a good thing and that's a bad thing, and I'm going to explain that. if you've got a piece of wood, it's got a little bow in it, a little arch or something in it, and you're trying to route a profile on it, because once you screw it down to a tabletop or a dresser top or whatever it is you may be doing, it's going to pull it down flat. The router table is going to give you an issue because it's designed with a flat level surface. It's designed to track it that manner, particularly if you're routing it and it's got a little bit of a cove this way and you're routing with the cove. On a table, if it's a little bit the other way, as you're going through, it'll kind of go with you. But if you're going the other direction, you're going to be in here mashing and pushing down and everything to try to get it done. That's a case where a handheld will follow that arc a little bit. And we'll look at all of that a little bit more. The reason I wanted to show you installing the plate is that it's an issue. Guys have problems. Now, like I said, you can make the template like you've got, but normally you can buy one with whatever lift or router you get, and it's precision cut on a CNC. It's quick, easy, and usually they're not very expensive. But I wanted you to get an understanding, and the other thing I wanted you to see was using a straight edge and a drill and these kind of things to make your patterns. Because one of the things that you're going to see through this whole series is that we will spend as much time, actually we're going to spend a lot more time working with the actual pattern making than we are normally making the cut. I've spent all day, and sometimes more, making a pattern to make a 30-minute cut. That's fact. But boy, when I got done, it sure was nice. And the other thing, by keeping your patterns, you can go back and repeat and repeat and repeat and repeat. So we'll come back and look at some more. All right. We mentioned briefly about the raising and lowering of the router. And we talked about how you can just take the regular standard router and just twist it up, twist it down. No big deal. Works fine. This is a router lift. And all of them have their own little peculiar things and this and that. But for the most part, simply the way they lift is that they're just very convenient. You can get under here, crank it up, crank it down. Really quick, effective, fast, and easy. But like this one, this is one that has this is just a plate, because I have a handle that's designed to go through the plate to the router, to a turn, to a crank on the router, and I can simply dial it up, dial it down. Don't need a lift. And of course, here's the Porter cable one that I showed you in the combination kit. That's a plunge, and this does the exact same thing. So the lists are endless, okay? Which one should you have? You know, the best rule of thumb is whatever you can afford, okay? Lifts are expensive, good ones anyway. Routers are expensive. But here's the thing to bear in mind. It depends upon what you're doing, all right? And no matter whether you build a router table or whether you buy one, you really want something that's strong and stable. That's important. When this puppy's running, there's a lot of horsepower going on and there's a lot of speed, so you want something that's going to be safe for you. Now you can look at my old router table and you can tell it's, I don't know how long I've had this thing, but it has sure seen a lot of work. But you know, also in my shop, I've got room for this big router table. Most of you don't. And to be honest, most of you don't even hardly have room for a smaller table. Is there an alternative? Yes, there is. And that's the reason I want to show you this. Remember earlier I showed you that this has got the fence? Now most of you are going to have a fence similar to this. But it doesn't matter, even if you've got, you know, a regular little fence. And most of you on your table saw will have a work surface to the right of the table saw. That makes the best router table there is. Absolutely fantastic. If I didn't have this, I'd have mine in my table saw. And I'll be honest, when I get through this DVD, that lift I got to show you is going in my table saw on my work table to the right. If you don't have one, make one. And because the cool thing about it is, particularly if you've got the longer fences on here, you can do just what we're doing here. We're using this, our table saw fence, and we can just, slide them in a little bit, out a little bit, we can adjust. But with that said, a lot of you don't have that. And that's okay. Here's something I want you to know about a router table fence, is that, guess what? It doesn't have to be perfectly square. All right. Now, I'm going to show you this fence. This is a box of MDF. I stapled it together. You could use some finished nails, some screws, it don't matter. And you can just see how pretty it is. And this thing has, man, it has caught the devil. I want to show you something. It's straight down through here. All I care about. I took a big old Forstner bit and wallowed out a hole in it, and I can stick my vacuum cleaner in it, and it works good. Now, because I got this fence right here, what I do is I bring it up, set it, and I take some clamps through these holes and I clamp it to this fence. Simple as that. And as you can see, there's all kind of holes cut in every kind of place on it for different bits. And when it gets a little too nasty, well, I throw it away and take a little MDF and make another one. But here's what I want to show you. Here's the funny thing about a router. Guys get out here and they just drive themselves nuts making sure it's square this way and square that way. Doesn't matter. They really don't. You know why? Router cuts at one point. It don't care if it's cutting that way, it just don't care. Because it's only going to cut at one point. Think about what I'm telling you. When a piece of wood goes down through here, as long as this surface is straight, it doesn't matter if it's cutting that way or that way. It's not like a table saw. Now, if you're using a miter slide, that's a different story. But only thing you got to do is make sure that the miter slide is square to your fence. Fence doesn't have to be perfectly square to the table. The fence has to be square. The miter slide's got to be square to whatever you're using as a fence. And that can be anything. Now, I'm showing you my box here. If I had a router table like this that I had made and I didn't have all these fences, what would I do? I would simply make me a box. I'd make me an auxiliary fence that looked like this. I would make sure this and this was square because I want it to set vertical. Also make sure your bit is setting vertical. And I would simply make it the length of this so that I could take and put a clamp here and a clamp on the other end to hold it to the table. Then I'd make me a box. And I'd just clamp that box to this so that I can make all kind of different boxes. All right? Getting crazy and fancy, you don't have to do. All right? Improvise. And this good old MDF's about as good an improviser as you can get. I went and bought a sheet the other day, and I don't know, it was 20 some odd bucks or something. Man, I can make more patterns and jigs and just keep on going. And then a lot of times when I pretty much done one in, I'll cut it apart and use them parts for something else. That's it, Don't complicate it. All right. But what I'm trying to tell you is on this miter slide thing is make sure that your miter slide, and you can make that too, is square to the fence. That's all you got to do. As long as this miter slide, I wasn't tied up against there. As long as this miter slide is squared to that fence, when you go down through there, check it out. When you go down through here, you're going to be on the money. Doesn't have to be, all this doesn't have to be just perfect. It's nice if it is, but it don't have to be, because you're referencing on one point. Okay? That's what makes routers work so neat. That's how come routers can go around circles, around all these little curly cues and do all these fancy little scrolls and do all of that stuff, because it's only working and pivoting on one specific point. What I'm trying to tell you is that there's two things you want. You want a fence that you can adjust in and out, okay, to be able to set depth. And remember me telling you about putting that box across there? Well, see, it's just like this one right here. This one's got slides with hold downs. And I can take this and I can move it any way I want. And what I'm trying to tell you is that you can create a pivot point out there, out here, and if I want to set an in and out on this, I can actually just move one end. And even though this is running off from my miter slide, if I'm just running an edge, it's not going to hurt anything. And if I'm using a miter slide on it, as long as I set my miter slide to the same angle as the fence, it's not going to matter. Because again, it's referencing off one point. Like I said, it's nice when they are straight. That's the reason I'm telling you about using your table saw fence, or your out, not the outfeed, but the work surface to the right. You know, you don't have to get crazy with these things, and you don't have to get super fancy. Now remember I mentioned earlier that I was asked what you can do with a handheld router that you can't do on a router table. Well, I think the biggest thing I can think of is to be able to maneuver and cut big panels. And I'm going to explain that a little more later. But you know, if you're making tabletops or cutting plywood and whatever, and you're in a small shop and, you know, trying to maneuver this stuff, it can be kind of tough, all right? And particularly if you're working by yourself and you got some big old tabletop out here, man, trying to work that thing across a router table, you know, to put an edge profile on, that's pretty hard to do. But the other thing you can do is you can do a lot of flush cutting. And we saw that doing the templates. Now, I want to come back and I want to look at doing that. You know, if you don't have a joiner, but you got a router table, then you got a joiner. It's pretty simple, actually, and a lot of you know about it and have seen it, but for those that haven't, we're going to take a look at it. I want to show you. All right, how do we do it? Pretty simple, actually. Very simple. One of the things, you know, you want some means of dust control. Now, this is a commercially available dust port and a little guard. But all this is, the premise of this is so simple. All I've done is I've got just a simple board. This happens to be a PCMDF clamped to a fence. You can screw it, whatever you want to do. And I've got a flush trim bit. We're going to talk about that in a minute. But this will be your in-feed table and your out-feed table, just like on a joiner. The only difference is your wood is laying flat instead of being held vertical. And what you want to do, I don't know how well you're going to see this on camera, but what I did is this in-feed part, it's cut nice and straight, but this in-feed, I took a 1/16 of an inch off from this point to this point, so that this sets out 1/16 of an inch more than the bit. This might actually be even a little bit more than that. But here's the key. You want to take your bit and you want to set this blade, your cutting edge, right even, perfectly even with your outfeed, this side, which is, of course, is a 1/16 wider than this side. And just make sure that the blade is right on the money with it. And you have a joiner. Okay, the bit is important. Several different things. Now this is just simply a straight bit, straight cut bit. You don't need a bearing to set up a joiner. And this does good, but it's just like the straight knives in a joiner. It's going to be, they do well, but they're more prone to chip out and tear out. Now, this is an older bit, but you're going to get, and it's exactly what we're running here, but you're going to get the premise. If you look at this, the cutting edge is actually set on a skew or on an angle, so that when it's cutting, it cuts in a shear motion, not just a straight chop like the straight bit. And then, of course, if you're using really unruly wood and you're willing to go the money, you can get a spiral cut. Now the spiral cut is going to act just about like a set of helical head knives because of the way it cuts. Virtually zero tear out. When you get a bit, you want a down shear or a down cut. Now, in a straight knife, it doesn't matter. In the spirals, they're going to come up cut, down cut. What does that mean? A down cut means that if when you're, and they're talking about the way the bit would act in a handheld router. So a down cut bit, if the router's sitting on top of the piece, means it's cutting, the action is causing it to cut down. What that does is it keeps a super clean edge on the top surface. That's the way it's designed. But when you take a down cut and you turn it upside down in a router table, then it actually becomes an upcut. Think about that. Because it's twisting in a direction to force the chips up. That's a good thing, because then your vacuum can pick them up. They'll both work, but a down cut, that reverse becomes an upcut, works a little better. Now, you can buy out here, there's all kind of commercial fences and this and that you can buy that allow you to adjust your fence independently of each other, and they make for super joiners. But the cool thing about this is that even if you got a joiner and you're getting into some, and you've got a straight knife, much like the flush trim bit or this regular straight knife bit, and you're getting into some really high figured woods and you're getting into some really gnarly grains or whatever, and you're getting a lot of chip out on your joiner, having a nice spiral cut or one of the shear cut bits to help you with that is a really nice thing to have, believe me. And just like what we were just joining here, this is some really curly Claro walnut, and it would be real prone to chip out. But using the shear bit or using the spiral cut, I get a glass smooth surface, perfectly straight. Joiner from a route.